All right, so for the geometric sequence, all right, in this case here, my first term is -4. And each time, my r is going to be 4. I keep multiplying by 4. So the rule is simply an, -4, 4 to the n minus 1. That's the rule. When I go to get A15, it's -4, 4 to the 14th power. So 4 to the 14th power, you're going to talk about numbers getting very high very quickly. So 4 to the 14th, and then we multiply by a -4. So we're talking about a number in the billions. -1073,741,824. Here, my A1 is 24, and my R is 1/4. So the rule, 24, 1/4 n minus 1. That's your rule. Okay? When I want A to the 15, or A15, 15 term, 24 times 1/4, 15 minus 1. So it's 24 times 1/4 to the 14th. That's what Jelani came up and asked. You're going to get a pretty darn low number. 1 divided by 4, and now I'm raising that to the 14th. And I take that number, I multiply by 24. My A to the 15th is going to be 7 zeros. And I'm going to say 89. Okay? Now, when you're given an R and one of the terms, it's going to be 1,280 equals A1, 4, and it's n minus 1. So it's really 1,280 equals A1 4 cubed. 1,280 A1 times 64, and we're simply dividing by 64 on both sides. This one goes pretty quick. So we're going to go 1,280 divided by 64. My answer is 20. So my A1 is 20. So A to the n equals 20 times 4 to the n minus 1. You always go back and write that original rule. I'm not asking for a sum of anything here. I'm not asking for what the 20th term is or something, so we can just leave it as the rule. The next one is the most complicated one. This is where you solve for A1 on both sides. A1 is 12 over R squared. Now I do 8,748 equals A1, R to the 9 minus 1. So 8,748 equals A1, R to the 8th, and it's 8,748 over R to the 8th equals A to the 1. That's the key, is getting the two fractions equal to A to the 1. Now you're going to set them equal. 12 over R squared has to equal 8,748 over R to the 8th. We cross multiply. 12 R to the 8th, 8,748 R squared. We're dividing R squared on both sides. 12 R to the 6th equals 8,748. You divide 12 on both sides, 8,748 divided by 12, and you get R to the 6 equals 729. My R is 3. So now I have my R. Now I use that to get my A1. I'll pick a point. I'll use the smaller one. 12 equals A to the 1, 3 to the 3 minus 1. Or, sorry. Is that original? original term. R3 minus, yep. So 3 minus 1. Okay. So my R is 3. I'm going to work with A3 to the 12. I can see what I made a mistake on. Okay, so 12 equals A to the 1, 3 to the 3 minus 1. So we have 12 equals A to the 1, 3 squared. A to the 1 is 9. So we have 12 over 9 equals A to the 1. There we go. And my 4/3 equals A to the 1. And now we just plug in. A to the n equals 4/3, 3n minus 1. I would check my work. If I plug 3 in here, 3 minus 1 is 2, 3 squared is 9, 9 times 4/3 is 12. If I were to plug 8 in here, I would do 3 to the 8th and times it by 4/3 and make sure I got I got 8,748. Sn A1, 1 minus r over n, 1 minus r. So my n here is going to be 10, my A1 is going to be 15, and my r is going to be 3. It's a lesson in putting it in your calculator. 15, 1 minus 3 to the 10th over 1 minus 3. So my numerator here is going to be negative 59,048. My denominator is going to be a negative 2. So when I divide by negative 2, it's 15 times 29,524. You multiply that by 15, my sum is going to be 442,860. And that's our answer. Okay. Be used to, comfortable, numbers are going to get that high. That's not an abnormal number there. Okay. Here, if I give you this, think about what you need. My n is 10. We know that. We need my r, which is 1/2. We also need my A1. I can get it from this information. All right, my A1 is going to be this. 40 equals A1, 1/2, 3 minus 1. 40 equals A1, 1/2 squared. That's 1/4. And if I multiply both sides by 4, I get 160. That's my A1. And now I'm just plugging in. 160 times 1 minus 1/2 raised to the 10th power over 1 minus 1/2. So when I do this in my calculator, I'm going to go 1 divided by 2, and I'm going to raise that to the 10th power. And we're going to get something like 0.999. I'm not going to round it though. 1 minus 1/2 is just 1/2. I'm going to take that number and I'm going to divide by 1/2. And I'm going to get something like 1.999 going on forever. And now when I multiply it by 160, I get a sum of 319,685. And there's my answer.